All right, guys, here we go. Test 29 review. Number one, just let's find the determinant. So remember, multiply this way first, negative 42. Multiply the other diagonal next, negative 20. You always subtract. Negative 42 minus negative 20 is negative 22. Anytime I ask you for a determinant, there's a one number answer. Number two is Cramer's rule. Remember Cramer's rule, if you're looking for the x, don't use the x on the top. So you use the negative 2 and the 1 where the x's would go. The y's are okay on the bottom. xy, all the time. So 1, 3, 4, 5, negative 7. The numerator there, I'm going to multiply, subtract. 14 minus 4. The bottom, same thing. Negative 21 minus 20. On the numerator, I'm getting a 10. On the bottom, I'm getting a negative 41. So my x is really just negative 10 41s. First, however you say that. Y, remember, the bottom's always xy, which means the bottom's going to be negative 41 again. My numerator, if you're looking for y, don't use the y's on the top. I can use the x's. I'm going to use the negative 2 and the 1s where the y's would go. Multiply, that's 3. Multiply again, that's negative 10 over negative 41. That gives you 13 over negative 41, which ends up being negative 13 over 41. So your answer is negative 10 over 41 and negative 13 over 41. Awesome. Number 3, evaluate the determinant. This is a 3 by 3. Remember, we start off the first step by recopying the first column outside and also the second column. And then I'm going to go, let me mix this up a little bit. I'm going to go diagonal. And do those first. I'm going to add those. 5 times 5 times negative 3 is negative 75 plus 9 plus negative 8. Then I'm going to go diagonal. And when I go that direction, I'm going to subtract. So I'm going to do minus 18, minus 5, minus 60. I'm just going to combine all those real quick. I'm trying to see my head real quick. Negative 66, negative 74, negative 82, negative 87. I think it's negative 147. That could be a little off. I did that in my head real quick. So you can punch those in your calculator to make sure, but pretty sure that's good. All right, number 4, find the inverse. I forgot to draw the brackets around here. Remember, we had a shortcut for the inverse where we did find determinant, flip, put it in the front, change first and fourth, switch sides on second and threes. That's what I'm about to do. So first thing, I'm finding determinant, multiply, subtract. I get negative 16. I'm going to flip it, put it in the front. I'm going to switch places with first and the fourth, change signs on the second and third. Then I'm just going to distribute that negative 1/16. Negative 2 times negative 1/16 is positive 1/8. Negative 8 times negative 1/16 is 1/2. It's going to be positive 3/16, and then it's going to be positive 4/16, which is really just 1/4. Number 5, solve using a matrix equation inverse, and you must show your work. The directions say show your work. This is a 3-step problem. First step is we're going to write the coefficients in a matrix times the variable matrix. That's going to equal what the constants are, the 2 and the 10. Now your job is to move that matrix over there, but to do that, we got to move the inverse over there. So if I do inverse, I'm going find the determinant, which is negative 6 minus 3, which is negative 9. Flip it and put it in the front. So I'm going to have negative 1/9 over here. Switch places with the fourth and the first. Switch signs on the second and the third. And I still have that 210 over here. And you must put that inverse over here first. Okay, so here we go. So I'm going to leave the negative 1/9 outside. I'm going to multiply the two matrices that are left. We're usually not going to cross and down. So I'm going to do negative 3 times 2 is 6. Negative 3 times 10 is negative 30. So I'm doing negative 36 and negative 6 and negative 30, which is negative 36, which I love because 9 goes in there. And then across down on the bottom row be negative 2 and positive 20, which I love because that's 18. So my final answer, if I take negative 1/9 of negative 36, I get 4. And if I take negative 1/9 of 18, I get negative 2. And there you have it. Number 6, solve by elimination. I think I'm going to make the y's go away. So I'm going to multiply that top equation. I'm going to bring it down here, though. Multiply the whole thing by 5, which would give me a 10x, a 15y, and a 5 times 15 is 75. Add the equations together. That gives me a 30x over here and a 90, which I love. So 30 goes in there 3 times. I'm going to take that and plug it back in the top, which will give me 2 times 3 plus 3y is 15. 2 times 3 is 6. So if I move that 6 over here, it gives me 9. And if I divide that 3 into 9, I also get 3. So got 3, 3. Worked out really good. Number 7, solve that equation. Don't forget, if you see 1 log, anytime you see 1 log, you should be getting good at this by now. You do the base to that power equals that. So I'm about to go 3 to the 3rd power equals 7 plus 2x. So 3 cubed is 27. I'll move the 7 over, I get 20. Divide by 2, get 10. Make sure it doesn't make the log negative. It doesn't. Good answer. Number 8, use the change of base formula. And you got 2 options here. Change of base formula says you could do this. You could do log 72 divided by log 7. You could also do natural log 72 divided by natural log 7. Or your calculator, if you go math, hit your math button, scroll way down, you're going to find a button that says something like log base, something like that. And it will come up. You hit that button, it comes up with a log, with a box, and a box. You just fill your boxes in. Let me see what the answer is real quick. And I'm getting 2.1978. Let's go 4 decimals on that one. Number 9, graph that exponential. Now, usually when I have an exponential equation like this, I'm going to graph the asymptote is on the x-axis, but because there's a -2 right there, the asymptote gets shifted down 2. Remember, your first point's always 1 above. I know it's growth because it's bigger than 1. I'm going to go 1 to the right of my first point. My first point's at 0. Kind of lawnmower outside, if you can't hear it. So I'm going to go 1 to the right, which means I'm going to put in 1. If I put in 1, I get 3 to the first -2, which is 1, by the way. So I plugged in 1 and I got 1, so my point's 1, 1. Also, we noticed this while back. If that base was 3, my second point is 3 above the asymptote. Yeah, that always works. So connect your dots, la la la, and you got it. There's your graph. Number 10, find a function with all this stuff being true. It says degree 6, so it means I gotta have 6 x's when I get done. P of x equals, it says -2 is a 0, multiplicity 3, so there's 3 of them. So I'm gonna put x plus 2 cubed, 0 as a 0. That's just x, multiplicity 2, so it's squared. And then finally, 3 is a 0, multiplicity 1, so 3 would be x minus 3. You don't need to put a 1 right there. If you add all those x's up, there's 6 x's. Number 11, find the domain. Remember, you can never have a 0 in the denominator of a fraction, so I'm going to factor that denominator, make it x plus 2, x minus 2, and ask myself, what would make that denominator 0? Well, there's 2 things, a -2 and a +2. So when I write my domain, I'm going to go all x such that x cannot equal either plus or -2, and there you have it. Everything else is good. Number 12, almost there. Expressed as a sum of difference. Remember when we did this, we've figured out that anything in your numerator of a fraction with a log is going to be positive. Anything in your denominator is going to be negative. So if I do that, if I break it up like that, I'm going to have log 7. And because there's 2 things in my numerator, those are both positive, and then everything in my denominator is going to be negative, log 3 minus log a squared. And then one more thing, don't forget the exponents goes in the front. So this second term, I'm going to put 3 log b. And the last term, I'm going to put 2 log a. Then you have it. All right, last one. Graph that thing and just determine if it's 1 to 1. So if I graph it, and you can use your calculator, okay, if I graph it, one thing I know is I'm going to have an asymptote at -3, which kind of blows it already. And then the graph's going to do this kind of deal right here. It's going to look like this and like this. And what you're checking to see is, does it pass the horizontal line test? And guys, no matter where I draw a horizontal line, I can only hit that graph 1 time. So is it 1 to 1? The answer is yepers. All right, so if it fails the horizontal line test, it's nope. If it passes, it's yep. All right, and you can, like I say, you can graph that on your calc if you want to. All right, hope that helps. See you tomorrow when you come in to make a great grade. Only 2 more after this. It's crazy. All right, see you then.